good idea participant. I'm pleased to welcome you to this event. We have gathered to share experience, knowledge and experience of AI area. My name is Maxim Poltratsky, and I have honor of presentation our program. About this workshop, it's first workshop with an ICTERI conference, but I will become an annual conference. This is also for me, it's a first experience, and I sincerely grateful for your support and participation. The main aim of this workshop is represent and reviewing result of SmartPL project. Now we have 6 articles, 6 research. 3 research is presenting within first section, and next 3 presentation will be presenting within second section. Each presentation will last 10 minutes and followed by 10 minutes for Q&A session. The first presentation, it's Natalia Volko and Natalia Kushnir, standing AI technology extracurriculum activities with teenagers. This is presentation will be present via Zoom platform. It's Natalia, over to you, and let's get started.
Greetings, dear colleagues. Can you hear me?
Yes.
Yes. Thank you. Moment. We would like to present to you the results of our research on the topic studying AI technologies in extracurricular activities with teenagers. Today, artificial intelligence has significantly transformed all spheres of society, in particular ways in running a business and implementing tasks, management process, working with information, and the education system.
Natalia,
I'm sorry.
the slides do not change in the screen.
I'm sorry for interrupt. For now we have your presentation like frozen. Did you already move from the first slide? Because we can't see. Yeah. Okay. Yeah, I can see your mouse. So
change it.
Try to switch in from slide 1 to slide 2 just to check if it works.
Yeah. I can.
Second window.
Can I send in? Stop sharing.
Okay. Let's restart the presentation. Thank you.
I can restart. Can I restart? Yeah. Yeah. One moment.
Hi, Natalia.
Oh.
You'd better open the presentation in the full presentation mode. And then share the screen with the window with the full presentation mode, and then it works well from your side as well. Yep, excellent.
Change it?
Yeah,
Oh, no.
take it.
Thank you.
Thank you.
The search of interest in applications of artificial intelligence in education is evidenced by the significant interest in publications indexed in scientific database, particularly Scopus. Research using keywords such as artificial intelligence, education, and teacher revealed substantial growth in 2019. The popularity of the search term artificial intelligence in Google Trends indicates that global interest peaked in December 2022 following OpenAI's announcement of open access to Gen3 and subsequently Gen4. At the same time, society is increasingly encountering cases of destructive and improper use of AI mechanisms. For example, the active placement of AI generate books on Amazon and similar platforms. These range from short summaries of books by real authors to guides on collecting edible mushrooms. Another example includes the generation of knitting, sewing, and repair patterns or instructions, their execution of which does not lead to the expected result. All of this causes real harm to people, lead to a waste of resources, and violates copywriting, including cases where neural networks are trained on works without obtaining permissions from the authors. The analysis of AI development trends, the dangers of its uncontrolled use, and the realization that AI has already become a part of the lives of children and youth prompt us to study the impact of AI on the education system. For this purpose, a review of publications in the scientometric database, Scopus and Elsevier, was conducted. As a result of the sampling, 67 documents were obtained containing the specified keywords. An analysis of keywords indexed by the system and cited by others revealed, in addition to the main terms used in the selected documents, other relevant terms such as personnel training, teaching, students, engineering education, and education computer. This also assisted in narrowing the search scope and selecting relevant indicators. The analysis of publications revealed 27 systematic reviews. These work are dedicated to the study of the following issues: teacher training on AI, directions for the use of AI in education, concepts and approaches of AI study, for example, AI literacy, black box, their shift from a technology-oriented approach to interdisciplinary focus, AI training programs for various target groups. The use of AI in educational process raises many ethical issues for educators, some of which you can see on slide. The part of researchers emphasize that attention is needed not only on data privacy issues, including informed consent, data confidentially, and based data set, but also on the data analysis process in biased assumption, transparency, and causal relationships. Also, the following training programs were presented for non-IT specialists, courses developed as short modules that use online resources. Mostly they provide a basic understanding of AI without focusing on a specific subject area. Programs designed for training students and for professional development meet specific professional requirements. Training for the children is project-oriented and has an applied focus. It is worth noting that only 2 publications were directly dedicated to the issues of teaching children about artificial intelligence. Our analysis has confirmed that the problem is underdeveloped. At the same time, one of the tasks of education system is to prepare a child for a successful life in the modern world of technology, of which AI is an integral part. Therefore, in our work, we focused on presenting an approach to developing and conducting classes with students as a part of a club work on artificial intelligence.
In previous research, we identify 3 stages in developing competences in studies during computer science lessons. Familiarization with AI capabilities, building custom machine learning programs using builders, and transition to programming. Analysis of the publication relevant that the first 2 stages are well represented. However, the 3rd stage to create an artificial intelligence system and machine learning models unrepresentative in the literature, in the article. As the tasks are typically associated with the university level study and involve a significant number of concepts and algorithms. Our objective was to determine the essential terminology, isolate and translate the simple text into terms and analogous accessibility to children age 10-16 and facilitate their development on machine learning models. Based on our research, we established the minimum necessary terminology used in AI work, including fundamental elements of AI datasets, algorithm prediction, classification of AI algorithms, and aspects of AI-based program operation, and identify the corresponding content. We have developed the plan for conducting an extracurricular session for teenagers. This session can also be held as interdisciplinary activity during lesson or divided into separate activities for STEM week. The lesson spans 4 hours and is designed to be conducted in settings such as summer camps or during scientific study research periods in school vacation. Depending on the age of stages, there is skill levels program can be either condensed and extended. And it can be divided to several parts. Additionally, the program features a variety of activities, including familiarization with terminology and concepts discussion, practical walks, and changes in location for active movement. Here is a description of some of the activities mentioned. Preview Bitesh. Previous slide, please. The choice of activities we characterizes by their effectiveness in demonstrated by the basic context while requiring minimal equipment. For example, game What is in the Bag? This game sets the stage of observing the process identification, highlights the importance of prior experience, and demonstrates practical experience as a foundation of data acquisition to learning and understanding how the human brain works. Such an expensive exercise sets a stage for the lesson. The focus there facts that there item which children can easily identify or responsibly infer their function based on available characteristics, shape, material, size, because they have counted such an item before and are familiar with it. If an item is not present or experience, we start finding analogies with other familiar objects. Thus, we build a prediction about what item might be named the closest similar object. Next slide, please. Yeah, terminology. In the presented program for teaching artificial intelligence, we have used a simplified definition of terms related to AI. The level of children's preference can vary significantly. Only 3% of scientists' publications related to AI studies include definition. Therefore, this topic is good for the future research and can be future developed and interpreted. This game is interactive and always very popular with children. It helps them understanding aspects of datasets formation, including quantity and quality, approaches to data classification, and introduces them to frequency diagrams. This game describes an activity that teaches children how to conduct specific research. In this exercise, we focused on data collection, classification, and anomaly detection. During the game, children become familiar with characteristics of collected data, such as quantity, quality, and representativeness. The goal of this activity is introduce the concept of object classification, the challenges of object identification, and anatomy detection. To conduct this game, several photographs are a requirement in which an object such as cat is difficult to recognize. Initially, children identify the features of objects. They then need to justify they believe the photograph depict a cat based on the identified features, specifying with the future support this exertion and what the minimum sets of future is required to identify a cat. This experience allows participants to creativity available data and view familiar objects from different representatives. For successful object identification, various examples of objects images are needed. There may be several possible solutions for the problem, and it is important to discuss their strengths and weakness. Whether they complete each other, their balance und conclude that there is no single correct situation. Next. In this project, students train the algorithm of recognized left and right hands. Typically, they create numerous uninformed images to define the hand. However, after running the recognition program, it often fails to correctly identify the hand if it is rotate 19 degrees or turn it palm side away or other. The conclusion draw with object data sets needs to be modified. The goal of this game is demonstrate how a decision tree works. This is a typical children's game where one person thinks of a word and other must ask question about its characteristic. Answers can be yes or no. To record the properties, the named attribute can be written on a board of the form tree. For the programming, we used Zoomy. We used basic methodology. Alternatively, any other artificial intelligence tool can be utilized based on a preference. With the widespread adopting of AI technologies, the ethical implication on artificial intelligence have become increasingly pertinent. However, we didn't touch upon the ethical use of AI, various contexts. To extend the lesson, the following issues can be discussed. Conclusion. Education program differ in their learning objectives. Our program emphasizes the study of AI algorithms and introduces the fundamentals of programming, creating natural networks, understanding the operation and the predictive nature of models. The program also places a strong emphasis on data handling. The developed program scales well for both short-term seasons and expanded courses. Future plans include explain the programs to include activities related to AI ethics and data security. Thank you for your attention. If there are questions, we try to answer them.
Thank you very much. Now question. Okay. I have a question. What's the main AI concept? Children learning for anomaly detection.
Main concept that programming part, while in literature, in article, there is so poor research from teachers from programming.
Thank you. Next presentation. Thank you very much, Natalia Vulko, Natalia Kushnir. The next presentation, it's AI in Open University ecosystem context, and presenter Tatiana Terlecka.
Shall I sit here? Dear colleagues, I'm really glad to present our research at the conference. It is called Artificial Intelligence in Open University Ecosystem Contexts. Let me try switch how. Oh, okay, it works. So the short structure of today's presentation is why actually we started to research this topic, what is the theoretical background of it, and the results of our research. We started with AI in the context of open university ecosystem with the questions that AI started rapidly developing, and it touched every sphere of university activities, and we couldn't just avoid it. If we can't avoid something, we need to implement it, to research it, to study how to use it. Also, we understood that AI needs some regulations for implementing in different university activities. How can we use it? What are the rules actually of using this, of using AI? We understood that we need some complex approach because we take AI in different spheres. We take it somewhere in teaching and learning, somewhere in research, somewhere in other activities of the university, and it's pretty chaotic. And we understood that we need some complex understanding of AI utilization, some complex solution for it. So we started with such spheres, with studying such spheres as education management, AI-driven smart education systems, academic research, university infrastructure, security, e-learning, and AI competence. So these are the main spheres we researched to work with our paper. The questions we asked ourselves is, do we actually need AI at universities? Are we ready for AI to implement it at in different spheres? And what are the spheres we can implement AI? So we started with ecosystem. Oh, oops. Oh. And what we understand on the open university ecosystem, we don't see it just as digital space, because digital space, it can't be divided from other aspects of university activities, from human resources, from material resources. And these are both virtual and physical campuses. These are all connections a university has with different objects, with different spheres, with other universities, with scientific structures, with businesses, investors, academic community, and governmental structures. So we need to understand how can we implement AI in all of these spheres and how to connect it all together. To start with, we conducted a survey and we asked different education process participants about their levels of AI utilization. We found out that a very small percentage is not familiar with AI, so that's almost everybody at least heard about AI and at least tried some program based on AI. Still, there is a big percentage of those who hardly ever used AI or have some bias and unwilling to use AI. The biggest amount of people are those who use a few AI tools. Mostly these are large language models, chatbots based on large language models, and pretty small percentage are those who actively use AI tools or research on AI and its utilization and or train other people on AI. We asked to also to estimate the impact of AI on different spheres of university from minimal, which is 1, and to maximum, which is 5. And we also found out that many educational process participants understand that AI is going to influence different spheres of university activities, such as education, research, management, image and reputation, digital space, infrastructure, social social engagement, partnership with other institutions, and openness. Still, some of respondents see it as a really strong impact, and pretty big percentage of respondents see it as average or not so important impact. To understand what the educational process participants think of AI influence on different spheres of university activities, we asked them to estimate whether AI is going to influence positively, negatively, or no impact, minor impact on different spheres. These are education quality, education accessibility, security, innovations in education, change of approaches to teaching and learning, and personalization of learning. A very big percentage of respondents are aware of some security issues that AI might have on different spheres of our activities, and also they estimate that there might be quite negative impact on education quality. Especially respondents state that AI might be used as a tool which is technically solving some students' problems with tasks they are performing, and it is going to kill students' creativity and critical thinking. We built up a model of open university ecosystem with integrated AI, and we divided such spheres as the technical and physical resources, digital system, and human resources. For digital system, we divided it into e-learning and individual learning trajectory. Human resources, these are management and administration and research. And technical and physical resources, infrastructure and security. For each field, we found the ways of using AI. For example, If we talk about security, that could be network security monitoring, intrusion detection and prevention, data backup and recovery, multi-factor authentication, and so on. So this is basically we divided the ecosystem of Open University and tried to research where AI can be applied and what we can do with it. It's more of an exploratory research as we didn't have opportunity yet to test all of that. And this is going to be for future research perspectives. The benefits of using an AI in different spheres are mainly lie in efficiency of daily operations. So we can automate some daily routine tasks, personalization of education process, support of decision-making using big data, and so on. And cyber threats detection, it can be done better than by humans themselves. Also, there are some important challenges we're going to face with AI implementation, such as data security and privacy. As we know that everything that is given to, for example, large language models can be used by some language models afterwards. So some data might not be secure if we don't teach how to provide data to AI. Ethical and legal issues, imperfection of algorithms, for example, some bias there can be depending on data on which AI was trained, and resistance from educational process participants, which is also a big challenge, as not everybody is ready to work with AI. For different spheres of university activities, we chose some spheres where AI can be implemented. For example, for administration and management, we divided that into administrative tasks and managerial tasks. Two administrative tasks that can be performed. These are automatization of routine tasks, schedules optimizations, students and employees support, for managerial forecasting for decision making, monitoring and efficiency evaluation, resources planning, analysis of visibilities in social networks. For e-learning, these are adaptive learning and personalization, intellectual assistance, assessment and feedback, analytics and forecasting, content creation, and plagiarism check, which is not properly working right now, but there might be mechanisms in the future that are better detecting machines. For infrastructure, these are issues concerning infrastructure and security. These are monitoring and optimization, monitoring and management. And for security, threats detection, security information, and event management, analytics of user behavior, and malware detection. For research and science, there are three main categories: research organization, visibility and dissemination of research results, presentation of research results, which might be not only search and selection of some information, but also its visualization and using some AI tools to present some results of the research. For each of these spheres in the paper are presented some tools which can be used. Some of them are free to use, some of them are paid or have both free and paid versions. So sometimes that is challenging to find some AI instruments that can be used in particular spheres, taking into consideration the university possibilities and financial issues. So to conclude, I want to sum up that integration of AI into university activities is an inevitable process. It is going to go on, and we need to adapt to it and to make some plans how to deal with it. And implementation of AI in higher education is not limited to teaching and learning, although most research papers, they consider teaching and learning, and pretty low amount of research papers consider other issues of universities' activities. The level of readiness of higher education to implementation of AI is rather low in most areas, and the results of this research can be used as a roadmap to choose and select some spheres which a university wants to dig into, and to use it as a roadmap for implementing some AI tools. Deep research on AI in every sphere is needed, and that is a future perspective for the research. And also the other thing that is required from many universities is designing a policy on artificial intelligence and its utilization in different spheres, which is going to be some complex document regulating not only teaching and learning, but other spheres as well. Thank you for your attention. Questions, please.
What AI concept or AI tool we use for identification user or security?
I don't remember the names. They are listed in the paper. They were listed in the paper. I can't remember all the names, but there were some tools in this sphere as well. So there, you can check in the paper better.
Thank you. The next presentation, it's web-based information system common information space for virtual exchange program. Presenter Olga Pavlova.
Good morning, dear colleagues. Could you please let me share the screen? Thank you. Can you see my screen?
Yeah.
Oh, sorry. Dear colleagues, my name is Olga Pavlova. I am Associate Professor of Khmelnytsky National University at the Department of Computer Engineering and Information Systems. And let me introduce web-based information system, common information space for a virtual exchange program. My colleagues Tatiana Hovorushenko, Sergei Lesenko, Irina Zasornova, Artem Boyarchuk, and Mariusz Mazurkevich have been working on this project for 1.5 years now. The project is performed in the framework of Erasmus Plus MOVEX project, and here you can see an international team of this project, which consists of the representatives from TalTech. This is the university from Tallinn in Estonia, from 2 universities of Georgia, from the Heracopia University in Athens, Greece, and from Polish University, Wrocław Technical University, and also from the participants from Ukraine. They are Kharkiv University of Radio Electronics, then Kryvyi Rih National University, and Khmelnytsky National University, which I'm representing. In 2020, the members of the European Commission have presented the programs for the implementation of virtual exchange in the university education. Communication from the Commission on achieving the European education area by 2025 and Digital Education Action Plan for 2021 till 2027, which is part of the Erasmus program. The MOVEX project is a part of such programs. The figure on the slide demonstrates the tendency of digital safe-paced online education market till 2023. Here we have the overview according to digital self-paced online education market overview company, highlighting the relevance of conducting research in this area. Here we can see some relevant statistics and key players on the market, the platforms we all know and use, such as Coursera, Udemy, etc. We conducted the comparative analysis of advantages and disadvantages of the popular massive online course platforms and their functionality, and made a conclusion that they are not apt to virtual students' mobility. Therefore, there is a need in development of such a customized platform. The methodology that has been taken into account is blended learning. That is a combination of instructor-led learning, for example, in classroom or virtually, and digital learning, such as self-guided or assisted. On this slide, we represent the popular blended learning methods and approaches that are flipped classroom approach, problem-based learning, design thinking in education, case-based learning, blended and online learning, inclusive teaching practices, peer assessment practice, and collaborative course design. On this slide, we propose the structure of the learning management system that consists of the following components, such as means of communication, i.e. technology, that is rapidly changing, then interactive learning experience for distance education, and we divide learners that we divide by 3 categories. They are K-12, i.e. children from the kindergarten till the 12th grade of the school, then higher education and work, which is industry, to ensure and to assess the lifelong learning, and leadership institution to utilize instructional developers, train instructors, and support instructors. Oh, sorry. On this slide, we propose the architecture of the common information space. The users are divided by 3 categories. The first one is unregistered user or guest that can perform registration or can be registered. Otherwise, they cannot see the content of the system, only the alert that only registered users can enter the system. The second category is registered user that is divided by 3 types of users. The first one is student, who can view the list of courses, do preliminary enrollment, or fill in the form, view the instruction materials of the course, complete the quiz, receive the decision about the course full enrollment from administrator, receive a certificate on completion of the course, and get support from the administrator, and receive feedback from the administrator in case of something needed. Then we need 2 roles from the university's partners of the program. the first one is enrollment specialist, who can view the list of students who were selected after the completion of the quiz, to validate the list of students who were selected after the completion of the course, and get contact information of the students for the appropriate course. That is all necessary information to register students in the local educational systems and in the system that is common information space. And also we need a facilitator from the partner university to provide the system with a list of students who completed the course. And the third role is administrator, that has duties to manage user access and permissions, design user interface of the system taking into account branding, provide support to users, accept a valid list of students, provide feedback for students who did preliminary enrollment, receive the results of the quiz completed by the students, create ranking and of candidates for each course, and provide students with a decision about the acceptance. Here is a use case diagram of the listed above roles that is more clear to understand for more like visual representation. And here we can see the results. We developed such a system taking Moodle as a basis and adapted it to the needs and requirements of the project. Here you can see the main screen, main window of the system, i.e. dashboard, with some welcome information and the login button on the right side. And here we can see the login form that students or other participants just need to fill in their username and password, and they will be in the system. Since the system is still in the development, we do not have the content itself, so we continue working on the content and on the improvement of the system. And in conclusions, considering the analysis of the recent researchers, statistics, and trends in the education, development of the web-based information system, common information space for virtual exchange program underscores the growing relevance and importance of online learning, blended learning, and virtual exchange for students in today's educational landscape. The proposed system aims to facilitate seamless virtual exchange programs by providing a robust platform for collaboration, communication, and research sharing among students and educators worldwide. The integration of online and blended learning methodologies within this platform offers several advantages. It enables students to access high-quality educational resources regardless of geographical constraints, fostering an inclusive and diverse learning environment. The common information space for virtual exchange programs leverages these educational approaches to create a dynamic and interactive learning ecosystem. By facilitating real-time communication and collaboration, it enhances student engagement and participation, leading to more effective and meaningful learning outcomes. And that is all. Thank you for your attention.
I have a question.
Yes,
In-
please.
I see in your structure there are more or some organizational parts of the system, and you said that context is still being developed. Would your architecture be combined with some roles considering this content creation? What roles could there be?
Actually, there is a facilitator from each university who just uploads the content, or enrollment specialist, they can be like one person with both roles. However, the content is previously prepared by the teachers who are the professionals in their subjects. We cannot just register all the academic staff of the partnering universities in the system. They just prepare their micro-credential course, and then the course is uploaded by the facilitator or by the administrator. The administrator is just one person for the project, and facilitators can be several people from all the partnering universities, from all the institutions. Considering your question about the structure, actually, yeah, it's good to add the option upload the content. However, we still consider whether it's better to add it to the administrator or to the facilitator's role. Because mostly this is the administrator's role to upload content and to maybe support and manage it. So thank you so much for the question.
Thank you.
Good morning. I'm from Kherson State University, and I have a question. Does your system support somehow the personalized experience for students with special education needs?
Actually, since it is a virtual academic mobility system, we considered it as a fact, like that all the students could have the access. However, there are still some issues with the students with some visual impairment because we used Moodle as a basis of this system, and it doesn't support all the models, all the necessary stuff to make this system maybe appropriate, is better to say, for students with visual impairments. So this is one issue. However, it is fully inclusive and is appropriate for all the students with the special needs who cannot do the physical mobility, I mean, to go abroad or to go to other university because of some issues internal in the country or maybe personal for the student. But it is still in development, so all of the maybe pieces of advice are welcome. We will consider it as a development team and to make this system better. Thank you so much.
Thank you very much for your answer. This is the last presentation with an first section. Now we have break. Thank you.